Hello, class. Welcome back. Hope you all enjoyed your nice, relaxing break. So now what we're going to be learning about today is I'm going to teach you about HTTP and some other related technologies as well. This is about how different servers or different internet-connected devices can communicate with each other through the web. We're going to talk specifically about the protocols that are used, which, to define that term, so there are strict rules about how these servers can communicate on the internet. And those rules are known as a protocol, basically saying, you give me this information that I'm expecting from you, and then I'll give you this information in response, and you respond to my response. There's a structure for how these conversations happen. But it turns out that there isn't actually just one protocol that determines how different servers can communicate with each other, different devices can communicate with each other. There's actually a stack of protocols that are involved in this, that solve different parts of this problem. So let me just show you real quick. So this is known as the Osi model. You don't need to know this too in depth, especially as a web developer, but it's a good term to be familiar with. I don't want the next time someone says this to you to be the first time you've heard it. So there are basically 7 different layers where we can talk about how data is transferred on the internet. At the lowest layer, you're talking about like physical electrical impulses on a copper wire that gets converted into zeros and ones. And at the top, in the application layer, we're talking about like HTTP, JSON data, the actual like meaningful kind of application data that we're going to be working with more directly as web developers. So we're going to be mostly focused on layer 7, the application layer. That's where HTTP is. But there are a couple other parts of this stack that I want you to know a little bit about. So I'm not an expert on most of these, honestly. I just know a little bit about a few of them. So the first protocol that we should be familiar with is the IP protocol. It stands for Internet Protocol. That's the network layer. So IP stands for Internet Protocol. You might occasionally hear me use the phrase IP protocol, which is kind of redundant. It's like saying ATM machine, but that's how people say it sometimes. Because the M in ATM machine stands for machine, so it's redundant. So the IP is the Internet Protocol. This is concerned with where things are on the internet. So we can locate them using an IP address, which is kind of analogous to a physical street address. It just tells you where this resource is physically. So maybe you've seen these before, but generally an IP address is 4 numbers separated by periods. So it might look something like 192.0.2.1. So something like this would be an example of an IP address. And based on just this number, you can actually determine like geographically where in the world a server is with reasonable accuracy, because there actually is some correlation between IP addresses and like physical locations in the world. So more specifically, there are a few different versions of Internet Protocol. When you see an address like this is specifically IPv4. So that's the 4th version of Internet Protocol. Formats the addresses like this. Some of you may have heard that the world is actually running out of IP addresses. Just with the rise of personal computers and like Internet of Things devices, and everyone's got 2 mobile phones or whatever, we're running out of numbers. So people are actually developing a 6th version of the protocol. And so IPv6 uses much larger numbers for addresses. So in theory, then we should never run out of addresses, even if everyone in the world has like 10 IP addresses of their own. So for my entire career, IPv4 has been the only protocol in use for internet protocol, but it's very likely that for you folks, if you have a long, successful career as a developer, at some point in your career, you will witness the transition from IPv4 to IPv6, and people are going to have to change. They're going to have to relearn everything they know about these IP addresses and how they work. Okay, so this is only one part of the problem, though. The internet protocol only helps us understand where things are, but it doesn't tell us anything about how the data gets there. So a few layers up in our OSI model, we've got the transport layer. This is a few different protocols can fit in this layer that are concerned with how we transmit data. So particularly as web developers, we're going to be using the TCP protocol. So what makes TCP special is that it guarantees that when you send a request, that the recipient will get the correct data in the correct order. So there's a lot of error checking that has to happen. So as web developers, when we send data, it's really important that the client receives exactly what we sent. We don't want data accidentally getting mangled while it's in flight and then nobody notices. So this protocol that we're using has some error checking built in. It might automatically retry requests that fail. But this does make it a little bit slower. So in fact, every time you make a TCP connection to a server, you actually have to make at least 3 requests in order to start the connection. So it's not just one request back and forth, but there's 3 requests right at the start, known as a 3-way handshake, where the client and the server go back and forth, just confirming that they are who they both think they are and that they're talking the same language. So long story short, TCP is a little bit slower compared to some alternatives, but it gives us some error checking that is really important to us developing reliable web applications. So the most common alternative to TCP that you might hear about is UDP. So the big difference here is that unlike TCP, UDP does not have any error checking or any correction. So it's optimized for speed instead of accuracy. So this is really useful for things like real-time multiplayer games, or if you're trying to get data from sensors that have like, live weather data or whatever. There are some situations where it's more important to get fresh recent data than correct historical data, where like, if the data is 2 seconds old, you don't care about it anymore. You just want to know what's happening right now. So there are some situations where UDP is the correct protocol to use. But as web developers, this is not going to be available to us. You're never going to really have the opportunity to send a UDP request. But for some reason in interviews, sometimes some interviewers like to ask about this, see how much you understand the web, and they might ask you to compare TCP to UDP. So the way you do that is just talking about error checking and the speed. Basically, UDP just sends all the data as fast as it can without checking if it was received correctly, whereas TCP tries to be more careful. And for some reason, there are a lot of jokes on this topic too. So I said before that there's like only 4 jokes in programming. This is one of them. So here's one example. Tell you a UDP joke, but you might not get it. The joke being, of course, that UDP is a less reliable protocol. So if you send a UDP request, the recipient may or may not get it. You don't get a confirmation. There are definitely a lot of other jokes on this topic that you can find online if you do a quick Google search. This was the least inappropriate one I could find, but there are probably funnier ones. Okay, so we've got one protocol, IP, that is concerned with where things are on the internet, determined by IP addresses. And like every time you type a URL into your browser is converting that domain name into an IP address so that it knows where that server is on the internet. So it knows where to send the request. So that deals with where things are. TCP is how we know how to get to where we're going once we figured out where the resource is with IP. But then most important is the HTTP protocol. So HTTP is the protocol that defines how applications can talk to each other, how they can share data and communicate. So as web developers, you're going to be responsible for understanding this protocol better than any others. So we're actually going to jump into a quick slideshow here. Talk about this in a little bit more depth. We can take some questions now if anybody is curious about anything I said before, but I do want to make it clear that the stuff that I just mentioned is context leading up to what I'm saying now, but it's definitely much less important. HTTP is what I really want you to focus on. But that being said, are there any quick questions before we continue? Andrew?
Maybe not completely relevant, but don't some people have like dynamic IPs so that their IPs are always changing?
Yes. So, like I was saying, how the world is running out of IP addresses because there just aren't enough numbers in that space. So you can kind of think of it as the world has already run out of IPv4 addresses, and there are a lot of like clever hacks that people use in order to reuse them. And so I think a dynamic IP address is one of those like clever hacks. They just kind of like, move IP addresses around from one server to the next. If someone's going to take their server offline, then, they doesn't need that IP address anymore. They can reuse it, give it to somebody else. I think kind of LANs had this idea in mind too, that like from the outside, everyone inside your home has the same IP address, but then the machines inside your network have their own local IP addresses, which is just another way to cope with the fact that there aren't enough public IP addresses available. So we're running out of space. So yeah, I think it's just a trick to deal with the fact that we're running out of numbers. Does that answer your question? Kind of.
Yeah, I realize that topic's like way more confusing, but yeah, on a base.
It's a bit confusing.
Yeah.
Also a little bit further out of my expertise. I'm not a networking expert exactly.
Yeah. I don't think LAN gaming exists anymore.
Not like it used to. All right. So HTTP, it's the Hypertext Transfer Protocol, originally defined in 1991. Like the name would imply, the protocol is primarily focused on transferring hypertext. So one example of that would be HTML. So this is, you can think of it as primarily a way to get HTML documents between clients and servers. Although the web has certainly grown a lot since this original conception, since now we're using it to share interactive applications. They're more than just text and images. So if you're ever wondering, like, why are things so difficult and awkward to do on the web, like especially CSS, it's because CSS was not designed for building interactive applications like we're doing. It was designed for, adding a little bit of color and font styling to text documents, and it just kind of organically evolved into what it is today. So that's why it's a little bit awkward in some places. So when you send an HTTP request, when we have this HTTP conversation, there's a specific rhythm that the conversation needs to take. The server can't just like proactively send data down to the clients. It has to wait for the client to send a request. Excuse me. So in an HTTP request, the client sends one request, the server sends back one response, and then that ends the connection. If the client wants more data from the server, they have to send another single request, get another single response back. And the server cannot proactively send any data to the client unless the client requests it specifically. So the communication is always initiated by the client, responded by the server. Question?
Yeah, it's actually related to this. So the sending requests and getting a response back, you're saying that the three-way handshake happens before any of this happens.
Right.
Okay.
So yeah, right here, I'm just talking about the HTTP protocol and how that conversation works. But I'm saying you're correct. Even before this one request and response happens, there are actually like 3 requests and responses that happen before this to establish the TCP connection so we can start making the HTTP request. But that's a different protocol. So when we're thinking about HTTP, we're not thinking about that part. In theory, they're kind of abstracted, so we can think about them separately. Definitely a good question, though. Okay, so more specifically, this is what an HTTP request and response looks like. So like on the left, this is something that your browser, this is something that your browser would send to a server. This plain text, these 3 lines of text. And then on the right, this is what your server might respond to your client with. And we're gonna talk through what all these pieces of data mean. So the first thing in the request, the most important line is the request line. There's 3 pieces of information in here. The first is the request method or the request type. There are a few different kinds of HTTP requests, and they really all like do the same thing for the most part. You're just sending data over to the server, but the server can see what type of request you sent and then choose to do something different with it. So I kind of like to think of it as a color-coded envelope system. Like if you're sending mail to some business or whatever, maybe they have a scheme where they expect the envelopes in different colors, that they expect their mail in different colored envelopes to know which department to send it to. Like maybe letters for the finance department go in green envelopes, letters for human resources go in blue envelopes, something like that. So it's not like the color of the envelopes itself like affects what you can put inside of it, but it's that the person receiving the envelope has some expectation about what those colors mean, and they're going to handle it differently based on what they know they're supposed to do with those different envelope colors. So here, get request, this doesn't like actually do anything different from other request types, but it is commonly understood to mean certain things. So we can kind of expect the server is going to do specific things. Ivan, question?
So how does HTTP connect with, or how does it work with CORS? So I remember like course being something like similar to that, where it like filters out what can be accepted or filters out what can be requested or received or anything like that.
Yeah, so it's a little bit early to get into that. We might touch on that later in the boot camp, but generally the idea is that when you send a request to a server that is not the same server that you're on currently, like if I'm on ivantrejo.com and your website tries to send a request to like hackers.com or something, that's a cross-origin request, send a request from one domain to another. And by default, that's banned in browsers. Your browser will see that you're trying to get data from a different domain, and it's just going to not let you use the data that comes back because it thinks that, you know, it's a security risk or whatever. So that's called the same origin policy. If you want your server to not work like that, if you have a server that you want to have publicly available data that any client can request it no matter what origin they're on, then you can enable something called CORS, which is cross-origin resource sharing, which lets you share a resource across different origins, you know, different websites, different domains. So that's like if you're building an API where people are going to be requesting data from it that are not like that same website, then CORS comes into play. But I'm hoping we'll get far enough through the bootcamp without that becoming relevant.
Thank you.
Satisfactory? Yeah, I don't want to get too deep into it. That's probably more than I need to say. So there's a request type. This is a GET request here, the most common type of request. The next piece of information in the request line is the path. This is where within the website you're requesting. So / is generally the home page or like the index.html. But this is a page within the website. So /bio.html is some, you know, hypothetical web page that you could have on your site. And then lastly is the protocol you're using. So there's a few different versions of HTTP protocol. I want to say, you know, 8-10 years ago, we were on HTTP 1.0, but nowadays every web server that you'll interact with is using HTTP 1.1. So here the client and the server are just confirming that they're using the same version of HTTP. And then after the request line, you can have any number of headers. So these are kind of like options or other settings. Like it's not exactly the data you're trying to send, but extra information about the request. There's one required header, and that's host. This is like the name of the website you're trying to contact. The reason why this is necessary is because you can sometimes have multiple websites at the same IP address. So just knowing the IP address of a server isn't always sufficient to actually like send a request to the right application. So HTTP requests also need to have the host, you know, the domain name that you're trying to contact. And then here we see an optional header. The user agent says what browser or just what kind of client is trying to contact you. Is it Google Chrome? Is it Firefox? Is it a mobile device or a screen reader or something? In practice, the user agent string is not very useful because most browsers will lie and try to say that they are other browsers. So I wouldn't worry too hard about what you actually see for the user agent string because it'll usually look pretty weird. And on the other side of things, we have a HTTP response. So there's, again, 3 pieces of information in the HTTP response. The last one, you know, is just the protocol. They're agreeing they're using HTTP 1.1. But more interesting is the status code and then the status message. So every time a server gives a response to a client, in addition to the actual data that was requested, the server should display a status code to say just generally what was the result of the request. Like, what did it succeed? Did it fail? Do you have to try again or something like that? And then there's a little text kind of saying in plain English what that means. So 200 is by far the most common status code you'll see. It means okay, it's just a generic success. The server did what it was supposed to do. But there's a whole bunch of other status codes. Let's just take a look at this real quick. I'm going to check out the Wikipedia article on this because I like the organization of it. So just looking at the table of contents, we can see kind of how these status codes are organized. They're all 3-digit numbers, either 100, 200, 300, 400, or 500. So anything that's between 100 and 199, that's informational. Your request did not succeed or fail. So those aren't very common. I don't see those a whole lot, honestly. Anything between 200 and 299 is some kind of success. Either, we created the thing that you wanted to create, we got your data for you, we deleted the thing that you wanted deleted, or just 200, which is a generic success message. 300, between 300 and 399 is for redirection. If you move your site to a different URL, you might have a redirect at the old URL to move clients to the new URL. Pretty common is 400 errors. So anything between 400 and 499, this is a client error. Scroll down to those. So these are some common examples of client errors. I'm not sure if anyone has seen some of these before, but probably the most common one would be 404 not found. Anytime you request something from a server that doesn't exist on that server and has no idea what you're talking about, the server should respond with 404, can't find what you're looking for. Other common ones are 403 forbidden. Usually means that you need to be logged in to do what you're trying to do. Or you are logged in, but you don't have the correct permissions for the action you're trying to take. Request timeout is pretty common if you're not able to get a response in time, and then it just ends the connection because it takes too long. But for the most part, if you get a status code that you don't recognize, you can just go to Wikipedia or whatever and see what it's supposed to mean, and then try to do some sleuthing and figure out what's wrong with your application. Probably my favorite status code is 418, I'm a teapot. This is actually an Easter egg, but it does work in browsers. You can return a 418 status code and the user's browser in the console will say I'm a teapot, which I think is kind of funny. Technologists are always trying to sneak in like jokes for April Fools and then get them actually standardized. So also very common, important to know about, 500 errors means that the server did something wrong. Now, very commonly, you're just going to send a generic 500 internal server error, meaning something went wrong. We're not really sure what, but we're sorry. Because generally, when something goes wrong on your server, like it crashes, and if you knew it was going to crash, you would have just written the code so it didn't. So commonly, server errors are unexpected, and so your web server software is just going to send a 500 response. But in theory, if you have good error handling on your server, you should be able to detect what is wrong and then send a more specific error message if that's appropriate. Andrew?
So you're saying like a lot of these are already built into like our server functionality, like 404 is like it's a bad one, but like if something's bad, we can cause it to return specific server errors.
Yeah.
Is it just like done in like JavaScript or like HTML too?
How you return the different server errors?
Yeah.
Since we're going to be using Django for our backend, that's where you would specify that. You receive the request in Python, you can analyze it, and then maybe you use like a try except block while you're trying to process it. And if you throw an error in the try block and it goes into the except block, then in there you would probably try to analyze, why did it fail? Why did we throw an error and get into the except block? What went wrong? And then what's the most descriptive error message that describes what went wrong? And then return that error message to the client. So yeah, this is all going to happen from Django. But in this lecture today, we'll be sending some HTTP requests and getting responses. So it's good to see that you're getting the appropriate response. So we want to get like a little look at what that looks like. I just opened my dev tools. I opened up the network tab. This is where you can see HTTP requests coming in. I'm just going to refresh my page. So this is Wikipedia. There's a lot going on here. The first item is just the HTML document. This is showing me what I downloaded there. We know the HTML document links in style sheets and JavaScript and images, so it has to send a whole bunch of other requests for those items. And it looks like these are all successful, so I'm getting 200 status codes for all of those. So that's great. But yeah, so generally, if you're not able to download things that you think you should be downloading, or a request isn't giving you the response you think it should, open your network tab, look at the status code for it, and see if maybe you're getting something unexpected. And so beyond that, the response can also have its own headers that is not the actual data you requested, but it's more information about the data, such as how much data was provided, when you provided it, and somewhat importantly is the content type. Because browsers will display different types of information differently, whether it's HTML or JSON or an image or a song. So it helps sometimes to specify the content type. Now, honestly, in practice, you're not going to have to think about this all the time, because generally speaking, your web server should be able to set this automatically. Like if you're using Django to send an HTML page, Django will automatically set the content type to text/HTML. If you're using Django to send a JSON response to an API request, it'll automatically set the content type to text/JSON. So you don't actually have to fiddle with this all the time, but there will be times when your server can't automatically figure out the correct content type, and so you might need to set it. Down here, this is just showing the body of the response. This is the actual data we were trying to request. So bio.html, and it gives us this HTML document back. So this is just showing you a little more detail I was talking about before. The request method here, it's get. This is I call it a path. Another name is URI. It's the Uniform Resource Indicator, I believe. And then here's the protocol version, HTTP 1.1. So I mentioned before, get is the most common HTTP verb. There's, I want to say about a dozen of them or so, maybe, but you are definitely going to be using these for the most. I would say like maybe 90–95% of requests on the internet are GET requests. Every time you type something into your URL bar and then press enter, that's sending a GET request to retrieve that page. When you're requesting the CSS files, style, or the scripts, images, those are all GET requests. So I would say, honestly, like 90%, 95% of requests on the web are GET requests. Second most common is a POST request. This is very commonly used for sending data to either create something on a server or to update a resource on a server. This is the second most common type of request. If you're using an HTML form, for example, you can only use it to send GET or POST requests. So we're going to do other types of requests later on because we're going to be using more advanced tools for sending these HTTP requests. But if you're just using a plain HTML form, you only have access to GET and POST. So those are kind of the classic two request methods. Less common, but still useful, still good to know about. Put, commonly used for updating a resource. Delete is commonly used for deleting resources. But bear in mind, sending a delete request doesn't force the server to delete things. It's still up to the server to read that request and interpret it and then decide what it wants to do. It's just that by convention, delete requests are commonly used for deleting or hiding resources. That's what they're understood to mean. So this is a very general kind of high-level overview of what these HTTP verbs are used for. Much later in this program, I'm going to be talking more in depth about how you choose different HTTP verbs in different circumstances. But for right now, it's not the next thing I want us to be focused on. So yeah, here's another look at the request line. That's the Uniform Resource Identifier. As I was saying, or I think I said indicator, identifier is close. Here we're just talking about some terminology. some kind of similar terms you might see. You know what a URL is? That's this full string with the protocol, the host, and then the path, the URI inside of it. If you leave off the protocol, that's just a URN, which is a uniform resource name, I believe. So depending on what parts of the full URL you're looking at, there's slightly different terms that you might see. So URI, URN, URL, these are all similar related terms. So yeah, here's just showing the request separate from the headers. But now we're going to add one new thing. So an HTTP request must have the request line, must have at least the host header. But then optionally, some request types can have a body. So you can attach extra data into the request. In this example, we're sending a post request with the body. That's because GET requests cannot have bodies. This is probably the only actual technological difference between the different request types, is that GET requests cannot have bodies. All other request types can have bodies. That's the only technological difference between the request types. Other than that, the only difference is just in how the server chooses to interpret it. So here we're seeing, this is called a query string or URL params, where you see key equals value and key equals value. So this is kind of like a dictionary in a sense, with two key value pairs that are separated by an ampersand. You'll also see commonly JSON data used as the request body. We're going to use JSON a lot. It's a pretty comfortable format to use. So that'll probably be our preferred format for putting data in the request body. So yeah, this is a more detailed explanation of the query parameters. You've probably seen before URLs that have a question mark in them. So that means that that's the end of the regular URL. And then after that is just extra variables, extra data that you're attaching. So I told you how GET requests cannot have a body, which usually if you want to add extra data to a request, you put it in the body. GET requests cannot have a body. So if you need to attach extra data to let the server know what you're asking for, you can put some variables after the question mark right in the URL in what's called a query string. So that's something you'll need to be aware of, just different ways that you can attach data to your requests and access them in the server. More in-depth description about headers, but talked about this already a little bit. So now we got a breakdown of the response. Again, it's got three sections: the status line, headers, and then the body, which for the response, the body is also optional. In most cases, the reason why you send a request is to get the body back. But there might be situations where you don't care. So if you're sending a post request to create new data on the server, maybe all you need to get in a response is that it was successful, that the data was created. So that would just be a 200 OK HTTP status code letting you know that it was successful, or maybe HTTP 201 saying that we created something. But you don't need any data in the body, because all I need is the status code to know that it was successful. Explaining the response line again, some common status codes. I already showed you a few more than this. These are definitely the most common ones, though. If I was going to make a top 6 list, this would be it. We talked about some response headers, common ones being content length, content type. Another very important one that we're going to dive into in some later weeks is set cookie. This is how the server controls cookies on the client. This is how we implement sessions so the user can be logged in to our website and not have to type in their password every time they go to a new page. So that's going to be a pretty important header that we're going to learn about a little bit more in depth later on. Now, I mentioned this before, but I think it bears repeating that sending one request, like if I just type a URL into my browser, that's a lot more than just one request. So typically, like your server will receive requests dozens at a time because it gets a request for the HTML and then immediately a request for all the CSS and JavaScript files and all the images. So it's like I showed you when I loaded Wikipedia, just on refreshing the page, there were dozens of HTTP requests that happened immediately. An important part of HTTP, another principle of it, is that it is stateless. So that means that the server shouldn't have to remember anything about the user from one request to the next. So like if you send an HTTP request saying like, send me all the movies Daniel Radcliffe has been in. Maybe there's too many, so it just sends you one page of results. If you said then, send me another page of results, the server might be like, I don't know what you're talking about. A page of results about what? You would have to say more like, send me page 2 of results for the question of what movies has Daniel Radcliffe been in. So every request to the server has to fully specify everything that you're expecting to get back, because it's not going to remember from your previous requests. Now, when cookies come into play, that kind of changes things because the server is able to look up information about the user if they're logged in and then handle that a little bit differently. But in the classic sense, HTTP is stateless and each request is independent of each other. So yeah, this is just kind of talking about that caveat of cookies. Like I mentioned, we're gonna cover these a little bit later. Don't worry about understanding these in depth at the moment. And yeah, so that's HTTP in a nutshell. Who's got questions? Andrew.
What you just said about HTTP like requests being sent through and all of them should be independent of each other.
Mm-hmm.
Is that something as we as web developers have to think about when we create our websites, as in like our product shouldn't have codependencies?
I wouldn't say it's something that you have to think about
Yeah,
because it's like there's just no other way that you can do things.
it just confused me a little bit because at first you said like for like the HTTP request for like an HTML document, you'll do your request for HTTP, your HTML, and then your CSS, and then your JavaScript, and they're all separate, but all of them rely on like the original request too, right?
Right. Like the server just knows that it's getting requests for an HTML page and then a dozen CSS files and a dozen images. The server isn't necessarily making the connection that all those CSS files and images are serving that HTML page because those are all independent requests. Make sense?
Yeah, yes, it does. It's just like the requests have to be separate from each other.
Right.
But the server can't do that thinking, knowing that stuff on your page might require other things to do together.
Right. It's kind of your browser has to be a little smarter and request the things that it knows it needs and then put them in the right place on the page. All right, so that's all I've got to say about HTTP at the moment. One other little bit of jargon I'm going to drop on you. We're going to be working with APIs today, which is an application programming interface. Is anyone familiar with this term? Can anyone tell me what this means, what they do, what they're for, why do we care?
It's a way to like add some of your own functionality to something. Like you can do it in Slack. You can make / commands that do whatever you want.
Yeah, that's an example of an API.
Accessing the server, maybe? Like
Say
Getting
again?
access to a server, just getting access to a server to push and pull information.
Yeah, it's about access, it's about information moving back and forth. So let me give you my definition. API is essentially a contract between two pieces of software that defines how they can interact with each other. So for example, every library that we've used so far, we're calling these functions of it, or like the Python random module, we're calling all these functions of it. You could consider that an API because all these functions have expectations about what you put into them, their input arguments, and we have expectations about what we should get out of them, the return value. So this is a contract, and it's defined in the documentation for these methods. If I go to the official Python docs, oh yeah, so it's even defined here. This is the Python/C API. So it's kind of showing like, this is how you can use the code, and this is what you should expect it to do. Maybe there's a better example here. So this I would consider as like a good example of what API documentation looks like. It's a list of methods you can call with a brief description of what you pass into them. This takes an iterable, this takes I and X, and a description of what you should get out of it. So this is not describing how these functions work under the hood. How are we inserting and removing from these lists? It's just describing the contract of what I can expect from these functions when I use them. So that's an example of an API. But most commonly, when people use the term API, we're talking about web APIs or JSON APIs. So more specifically, we're talking about the ways that our front end code can reach out to someone else's server and then get their data and pull it into our application. And so that person who has that other server, they would publish some API documentation, a contract that describes how other clients can request their data and what they can expect to get back in that request. All right, so I just wanted to define that briefly. We're going to be using some APIs, but I don't have too much more to say about the term. People have any questions about that real quick? Nothing? Okay. So next acronym I'm going to drop on you. I'm sorry, there's a lot of alphabet soup today. Ajax. Has anyone heard this one before? I'm hoping somebody has. Can you tell me what it means?
I think it's just, I feel like I've used it before, but not in a real understanding it very well kind of way. But I think it's just a way to make API calls a little bit easier. I think it's like a framework for them.
So asynchronous JavaScript and XML.
Yes. So this does stand for Asynchronous JavaScript and XML. Like Kat was saying, this does help us send web requests, but I would say it's not a framework. This is a technique. Like there isn't one library that you use for Ajax. It's like a style of programming. There are a variety of ways you can achieve this. So for context, there are many ways that you can send an HTTP request. Such as clicking a link, typing a URL into the browser or submitting a form. But for each of these three methods, when you submit an HTTP request this way from your browser, as I'm sure you're aware, this unloads the page. So it just blanks out the screen, you get a white screen. It clears all your JavaScript variables, and then it loads everything in fresh from just whatever you downloaded from that request that you made. So for the longest time, this was just how the web worked, and we didn't have any other options. But in 1991, actually, Microsoft invented this new API. They added this feature to Internet Explorer called XML Http Request. So this actually still exists in browsers. It's just like built right in. So yeah, XML HTTP request, it's a function. I can still use this today if I want to send a request. I'm not going to do that, but for historical reasons, I want to show you it's still here. So they added this object, XML HTTP request, that lets you send HTTP requests without unloading the page. So you can quietly send a request for data in the background while the user is reading stuff or whatever, and then update elements on the screen individually instead of replacing all the content on the page. So a lot of people think that this is generally a nicer experience because you're only changing, one thing at a time, whatever you get new data for. You're not blanking out the entire screen in between like every click. And so like we said before, Ajax stands for Asynchronous Javascript and XML. Asynchronous JavaScript just means that you're sending this request in the background while other things are happening at the same time. Because an HTTP request can take, on average, maybe a few hundred milliseconds, which might sound fast, but in terms of like computers doing things, that's actually one of the slowest things you can do. And it's slow enough that a user can notice it. And if you have to do a bunch of HTTP requests, that can definitely add up to a few seconds. And there's some statistic that's like 90% of users won't wait more than 2 seconds for your page to load or something like that. So the fact that we can do this in the background while other code is running is really useful. It's an essential part of this technique. And then the XML is just the data format. So XML is a format of data. It looks kind of like HTML, but it's not specifically for documents. It's for any type of data. Although honestly, we don't really use XML very commonly anymore. So instead, we're going to be using JSON. But we still use the acronym Ajax just because it sounds cool, and Ajaj, like asynchronous JavaScript and JSON, just sounds really dumb and it's hard to pronounce. So even though almost no one is including XML data in their Ajax requests, this is still the acronym we use to describe it. All right, so more recently, there's another way that we can send Ajax requests in our browser using an API called fetch. Just gonna sneak another acronym here, XML HTTP request. You'll often see people refer to this as just XHR. I think that acronym might come up at some point in the next couple of days. So fetch is this new method that's available to us in browsers, provides the same functionality as XHR, but is just much easier to use. For starters, it's much easier to say, like fetch versus XML HTTP request. I think I've stumbled over that word like 3 times already in today's demo. So even though it's nice that this exists in browsers, like again, just right there, it's predefined already in the window. It's a function, native code. There's an even nicer, even more convenient way that we can send Ajax requests. So today, I'm going to be introducing you all to a library called Axios. So Axios is a modern and convenient HTTP library for JavaScript. So this is what we will be using to reach out to other servers and use their data in our applications. All right, so this concludes the theoretical part of this lecture. From this point on, we can ask questions, take a break, and when we come back, I'm going to be showing you some code about how we can actually work with Axios and actually send requests to an API. Before we take a break, does anyone have any questions? Any questions? APIs, Ajax, what do all these acronyms mean?
Raphael, I have a question more on the HTTP, and that would be, what's the distinction? Is there any for what we need to do with HTTP and HTTPS, or is that simply it's just going to encrypt it? Like, does it affect us in developing at all?
I'd say you got it right. It just encrypts it. For what we're doing right now, it's not going to really have any effect on us. HTTPS is exactly the same as HTTP with encryption before and after you send and receive the request, so people can't snoop on your traffic. But in terms of like the skills you're developing and the logic you have to use, it's completely the same. Good question though.
I've seen a lot of like articles on like REST APIs. What is that?
Yeah.
A REST API.
So remember in that slideshow, I showed you generally what the different methods are used for. Like get is generally requesting data, post is generally for sending data. So that's kind of generally how they're used, because I don't want you to get too bogged down in those details. I just want you to start building APIs and sending and receiving requests. But there are specific styles that some people have adopted. The most popular of these is REST. So REST is a specific style of building APIs that has conventions for how you name your URLs, has conventions for which HTTP methods like get or post, which ones you use in different circumstances. It just has a lot more specific conventions about how you should build your API. Because what you're going to find out tonight is that using APIs generally requires reading lots of documentation in order to figure out exactly what you need to send and what you can expect back. But if that API conforms to a specific convention, REST, and then the other people consuming that API also know that convention, then they can kind of start out like on the same page a little bit more. You don't have to read all the documentation quite as closely because you kind of already know how it works if they've built it in a conventional way. So that's definitely something we'll be talking about later on towards the end of the program. That's like a little bit more academic, and it's just not what you need to be focusing on at this point, in my opinion. Sound good?
Yeah, sounds good. Thank you.
Mm-hmm. Any other questions at the moment? Andrew?
Since we're about to end a theoretical question, almost everything that we talked about today is built off like some IP protocol from like the 1980s or 1990s,
Yeah,
and it just perfectly works. Is there like
I wouldn't say
any
perfectly.
I mean, is there like any chance like the internet could maybe like like could change to like a different protocol in the future?
I mean, it could, but it's very hard. The problem is that once you publish something and you make something a standard, and then people will start creating clients that are expecting that standard. And so then if you want to change that standard later, there's already, thousands, millions, whatever of websites and browsers and other internet connected tools that are expecting the internet to work in a certain way, and they would just break unexpectedly. So let me actually show you, because you asked, let me show you what I think is a particularly hilarious example of that. So referrer is one of the potential HTTP headers. It basically, like if you get, I think it's like if you click a link that takes you to a website, that website will get a header saying where you clicked the link from, who referred you to that website. But apparently when this header was first used, someone spelled it wrong. Referrer is supposed to have 3 R's in it, but the header is spelled with 2 R's. But like, since they published it and then people started using it in their applications, it was very quickly too late to change it. And so now this is just permanently baked into web standards, is that the refer header is misspelled. So yeah, ideally people can identify these problems and bring us to better solutions, but backwards compatibility is a big issue on the web. You can't just force everyone to update. Any other questions?
Hi, Raphael. Can you show how the Axios work, I guess, for some examples of it?
Yep, I'm certainly going to show you how Axios works. That's going to be the rest of today's lecture. I just wanted us to take a break before we dive into the actual coding.
All right, thank you.
I have a question. Well, kind of a question, kind of a comment. I didn't put this in the today's retro, but I should have. But I think it's really nice whenever you like condense everything you just taught into like key ideas. So I guess what would be like the key ideas for what we've been, at least with like APIs and everything you've talked about with HTTP requests and APIs.
Let's see. One of the most essential concepts is probably just the request response cycle. So just knowing the rhythm of how you communicate with the server. The client sends one request, the server sends one response, that ends the communication until the client sends another request. Server cannot proactively send requests. So that's important to know. And then the general basics of what an HTTP request looks like. So like, being able to use the network tab, look in HTTP request and say like, okay, these are the headers. This is what I think they should be. These are the response headers. These look like what I think they should be also. Like, if there's a response header that says content type text HTML and you thought you're requesting JSON, then something is wrong. And this is how you could check that something is wrong. Or if, content length is 0 when you were expecting to get more than 0 content, that's another way that headers can show you where something went wrong. So understanding generally the structure of an HTTP request. It's got, headers and a response. What am I looking for here? Oh yeah, and so this is the general like request line, just the URL, the method. Or I guess this is actually both the request and the response here. Request method and the response status code, but kind of like the highlights. So let me think. Just generally knowing what an API is, that it's someone else's data that you can consume. Let me see here. Yeah, the rest of it is kind of like background context that if you have to debug some weird issues that might come in handy. The TCP versus UDP thing is something that interviewers might ask you about. But I would say knowing what an HTTP request and response is supposed to look like is very important. A lot of the like lower level networking stuff is maybe a little bit less essential. Wow.
Thank you. I just have a really basic question about the API. I was saying by using it, we're allowed to interact with the data from someone else. Like, would you mind make examples? Like, how's the APIs allowing us to using what type of data, like from someone else? Like, do you mind like providing example?
Yeah, after the break, I'm gonna drop some demos, or I'm gonna code up some demos using Axios, consuming data from a real API, and then building a tiny application with it.
Okay, thank you.
Any other questions? All right, let's take a real quick break. If we could come back at 11:25, and then I'm going to show you how to actually use Axios. Hello, everybody. Welcome back. Hope you enjoyed your break. So now I'm going to show you how to actually use Axios. We're going to consume data from a real live API. Get excited. So first, you're going to need HTML file. All right, so if I'm going to use Axios, the first thing I need to do is include it in a script tag, just like most JavaScript libraries. So I'm going to get it from a CDN, just Googled CDN Axios, comes up with cdnjs.com, probably the most popular CDN for JavaScript libraries. Takes me right to the link for Axios. See here, this one copies the URL. This button is going to copy an entire script tag, so I'll just click that. Just paste that into the head of my HTML document. So now I've included Axios into this file. Now I'm going to add a script tag for my own script. Note that I put my own script after Axios. I need to make sure that Axios is loaded in first because my script is going to be depending on it. That main.js file. Just going to put a quick console log in here just so I can confirm that it's actually connected. All right, let's try to bring this up in our browser. Make sure this works. All right, we're running on port 8000. So let's go there. Blank screen, kind of what I was expecting, but if we look in the console, we got that high. Okay, so it looks like our JavaScript file is connected. So next thing we need to do is actually find an API to use. So for the purpose of this demo, I've decided to use the Pokemon API because it's fun and frivolous, but more importantly, it's really easy to use. You'll find a lot of APIs are hard to use either because they require authentication, like you have to log in, manage keys before you can send requests, or they just have terrible documentation. So Pokemon API is honestly one of the easiest ones to use in my opinion, because you don't need any authentication. You can just send requests, they give you responses, and it is very well documented, but you can even use it pretty well without reading too much of the documentation, because I think it's really well laid out, fairly intuitive responses. So this is kind of showing you an example of how you can use it. The base URL is pokeapi.co/API/v2. And then after that, there are some specific paths you can request. So you can request information about specific Pokemon types, specific abilities. And then after that, after a slash, you put an ID number for which Pokemon or which type you want. So here we're searching for Pokemon/1, and this is an example response. Note that this gives you a ton of data. This is generally speaking going to be one of the challenges in working with APIs, that they will give you way more data than you care about, and you're going to have to kind of dig through it to find what you're looking for. But we can see a few things here. Looking for Pokemon number 1 tells us the name is Bulbasaur. I don't know if any of you guys remember your Pokedex from the 90s, but he is in fact the first Pokemon. Gives us some more information about him, like all the different moves that he can learn, all the different games that he's appeared in, which I assume is almost all of them, or maybe not. I haven't played Pokemon in a long time. Or even pictures of that Pokemon. So there's like a PNG linked in here. Just look at that. That's what he looks like, a little Bulbasaur from the back. And then there's other things you can search for aside from individual Pokemon. So if I search for type/3, this shows me the type flying. There are different types of Pokemon. Some are flying, some are electric, some are, fire, water, whatever. So I guess type 3 is flying. So this is all the information about it. These are all the different moves that are flying type. And these are all the different flying Pokemon. Charizard, Butterfree, Pidgey. They've all got wings, they fly. And then this gives you a URL then that you can use to find more information about that resource in particular. So let's get this into my own code now. Just copied that URL. Now in my script, what I'm going to do, I've already got access to Axios. So I'm going to go with Axios.get. It's got a whole bunch of different methods on it for different types of requests. I'm only going to be using GET requests for the Pokemon API. So I'm calling Axios.get. Commonly, when you're dealing with third-party APIs, you can only send GET requests because they're not going to let you update data that isn't yours. They're just going to let you view a copy of it. So most public APIs don't let you send post or delete requests. It's just GET. So I paste in the URL that I want to get. So that's the base URL. There's the specifics. Okay, so that's what sending a request with Axios looks like. But we need to actually store the response in a variable. So I'll create this variable called request promise that gets the value of whatever we get from Axios.get. Let's see what that is real quick. So I logged it, and it tells me it's a promise that is pending. So something has not been resolved yet, something has not been decided yet. That's because when I call Axios.get, it doesn't actually give me the data immediately. So remember I was saying before that it takes a few hundred milliseconds to send an HTTP request, but we don't want our program to be waiting around while that happens. So what is returned from Axios.get is not the actual data from this API, but it's a promise object that lets us specify what we want to happen in the future when we actually do get a response from the API. So this is kind of why JavaScript is complicated. Why this is what makes JavaScript hard compared to other programming languages is the asynchronous programming, all the different things that we might have happening at the same time and understanding what order everything is going to actually occur in afterwards. So now that we've got this request promise though, promises, so promises let us specify what's going to happen in the future when the request is either successful or it fails. So the way we do that is every promise has a method on it called .then. You call .then and then pass a function into it. And then this function will be called whenever the request succeeds. It's not going to happen immediately. It's going to happen some unspecified time in the future whenever we actually get the data back from this API. And then when we do get the data back, it's going to be passed into our function as a parameter. I'm just going to call that response. Let's just look at it. Okay. So I'm console logging the response now that we get. So this is what gets passed into our callback function. This is the actual response from the API. So first, it's kind of some general information about the request and response. So this is just a copy of the original request that was sent. And you can see here, it's a copy of, or an instance of XML Http request. So that thing that I was talking about before, it doesn't go away. It's still underpinning all of the Ajax requests we're doing today. It's just that we have a more comfortable and convenient API, a more convenient interface to send these requests. But under the hood, it's still XHR. We can see the headers for the request, status code, very important, but most interesting right now is the data. So here's the actual response from the API. This should look pretty similar to what we just saw when we were testing it on their website. So, the name of the guy is Bulbasaur. He is Pokemon number 1. He's got 2 types. He's a grass type and a poison type. So the data is nested pretty deep. I know there's a lot of like arrays inside of objects, inside of arrays, inside of objects. That again is one of the challenges in working with APIs, is that your data is going to probably be very deeply nested and you're going to have to drill deep to get the things that you want. So you have to make sure that you understand the structure of the response. So it's useful for me to look through it in the console like this, so I can just open and close individual sections and try to search for what I'm looking for. I could probably also just read the documentation and find where the thing I'm looking for is, but I like kind of doing this interactively. Okay. So let's get another example. All right, so now we're going to look for Pokemon number 151. But I'm going to format my code a little bit differently. So here I assigned the return value to a variable. We got this request promise, and I'm calling .then off of the request promise. So I wanted to show you, what gets returned from Axios.get, and that we can, do stuff with it. But commonly, people would combine these 2 steps into one. So I'll do that here, just Axios.get, and then .then response. So there's a response for a different Pokemon, pretty similar. This is Mew, number 151. Now, so it's important to know that .then also returns a promise. Well, actually, let's back up a little bit. So there are other methods that you can call off of .get. So there's also .catch, which this is how we do error handling with promises. If we think that there's going to be an error that gets thrown while we're requesting this page, then we can pass in a function that describes what to do with that error. So actually, we'll go back to this previous example real quick, and I'm going to break the URL. So https : whatever, this is not a valid URL. The request is going to fail. If I refresh the page, we can see all of these errors here. This is not a valid URL, so the request fails. Network error, it's bad stuff. So maybe though, when I'm writing this code, I'm thinking, this might not be successful. Maybe it'll fail. I should prepare for that. So what I can do is say .catch, pass in a function. This function is going to take one argument, that's the error. Now let's just console log it. So now when I refresh the page, some of those errors still throw, but one of them, at least, we're not seeing. I guess there's still some stuff that it doesn't like that went wrong. But at least it doesn't break our program. Our code is able to continue because we've handled this error with .catch. And then we can actually print the error message here. So it's, network error. Ivan?
Is there a reason, I might have missed it, why you put Python -m instead of Node or anything like that? Is it Python has to run it? I don't know if I missed you explaining that part.
Yeah. So I just wanted to run a simple web server to serve these files, the index.html and the main.js. So Python has a built-in module that lets you create simple web servers. So it's really perfect for just this purpose. I just want a dead simple web server just to send a couple files for this demo. So I can get that with Python -m HTTP server. There's a similar way I could do that with Node. Node also has a built-in, very simple HTTP server, but I thought it would be nice to just do it with Python because we've been using Python for the most part. It doesn't matter too much. Cool.
I have a question.
Yep.
So line 12, is that basically in case the API goes down, or is it just any error?
So this will catch any error, but there are a lot of reasons why that could happen. Definitely API going down could be one, or maybe you just typed the wrong URL in. Like here, there's nothing wrong with the API. I typed in a bad URL. Trying to think. Yeah, it's probably most likely network errors, but if something else went wrong, this should also catch it. So, Bao?
I'm sorry, just following the previous question. So when it catches the error, does it still allow the program to run, or it just present what kind of error it caught?
Yeah, the point is that it should allow the program to continue running. And instead of just bringing everything down, you can see what went wrong and then use some if statements or whatever to decide how to handle it gracefully.
Okay, thank you. So it doesn't really stop the program from continuing to.
Right. We want our program to continue in all cases, if possible.
Thank you.
All right. So another important thing to know. So I said promises, they have both a .then and a .catch method. So .then and catch both return promises themselves, which means that you can continue chaining .then and .catch off of them. I'm not going to get too crazy with this concept, because you can definitely just have a huge chain of .then, do like 10 things in a row. But I just want to show you, this is conventionally how you handle errors with promises. So first, we've got our optimistic case. After we send the request, we want to, console log the response. And then we chain off of that the error handling. If something goes wrong in any of our promise operations here, either in the original request or in our .then it should go to this catch block. So it tries to send the request, fails, you get that oops network error. But in theory, it should also catch errors that happen here in the .then. So I'm trying to access a property that definitely doesn't exist. So that should throw an error. But we don't get the red text in the console because I caught the error with .catch, and it's able to tell me calmly, cannot read property of undefined reading bar. So this is commonly how you would handle errors using promises. But let's make this a little bit more sophisticated, more advanced here. So I'm going to look at the response again. Now, one of the really great things about this API is that every response contains many more links to show you how you can continue exploring this API. So, for example, in types, it gives me this URL that'll show me all the other Pokemon that also have that type. So if I want, I can programmatically try to explore this API. So because I was just looking at it, I know that response has a property called data. Actually, let me just double check. Data has a property called types. Data.types. Types is an array with one element. So response.data.types 0. So that element is a dictionary. It has two properties, slot and type. I want type. Types 0.type. And then inside of there, type is another dictionary with name and URL. But URL is the one I'm looking for. So I want to get more information about this guy's type. Like that URL, is that right? Yeah. Excuse me. Oh, of course. What am I doing here? That's how you code. So I'm assigning to a variable the actual URL and then just passing it into Axios.get. There we go. So the first response tells me information about Mu, and I can find out which type he is. The second response gives me information about that type. So I open it up, look for data. And then here I can see, for example, Pokemon. It shows me that there are 123 other Pokemon that shared this type. I believe Psychic was the type one we're looking for here. So here we got Execute. I think he's like Grass and Psychic. Oh, that just showed me Mew again. Whoa, Buffett. These are some newer Pokemon. I'm not familiar with these. Again, I stopped playing in the 90s. But I'm just going to trust that this is a good API and it successfully gave me the response I asked for, and that these are all other Psychic Pokemon. Oh yeah, Abra, definitely Psychic, Kadabra. Okay. So this is something that you'll probably need to be able to do. Send an API request, and then based on the response from that request, send another request. What do we all think about this? Cool stuff, right?
Who do? Instead of doing dot then and dot catch, could you do like a try catch block? Or is there already prefer doing dot catch and dot then, training them like that?
Yeah, you cannot use try catch like you normally would with promises like this. You have to use dot then dot catch. That's a really good question, though. I think that actually leads into my next topic, which there are a few things that people don't like about using promises. One of those is that you can't use try catch like how you would normally. And the other problem is the indentation. So you notice here, I do one request, and then for this callback function, I indent. Based on that, I do another request, and for the callback function, I have to indent that. But what if I do another request inside of there?
And you still have to error handle all those separate requests too, right?
Yeah, it gets ugly. And we get another one in here. And so you can see as I'm doing more sequential actions, we're indented deeper and deeper. Now, in my mind, this isn't actually very complex code. I'm just doing one thing after another. But it's just the nature of asynchronous programming and how we have to write code with promises that it just ends up getting indented deeper and deeper and deeper. And this becomes very hard to read at some point. People call this the pyramid of death or pyramid of doom in JavaScript because you get this kind of like triangular shape on the left side of the screen. So we would like to find some way to avoid that. So the way we do that is with another technology in JavaScript called Async Await. Let me just show you, I'm going to code up a quick example here, and then we'll talk about it. Okay, so I've now coded up a function that should perform similarly to what I was doing at the start of this demo, but using a much nicer syntax. So first of all, just to be clear, we are still using promises here. Async Await is an abstraction on top of promises. So I really love async await. I use this all the time in my own code, but it's important to note that when your async await code breaks, the thing that you will be debugging are promises. So these are still very much used. You very much have to understand how promises work, but it's nice that we have this extra syntax that lets us write our code in a prettier way. So something to note about this function here is I've added this keyword async. If you add the async keyword to a function, that means that A, it runs asynchronously. The rest of your code is not going to wait for it to run, but also it means that you can use the await keyword inside of it. So I can only use await here because I use async here. Okay, so here's the magic. Anytime a function would return a promise, you can await that promise to instead just get the value that it should return eventually. So in this situation, Axios.get, this takes like a few hundred milliseconds to run. And so JavaScript is prepared to let me do other things in the meantime. But if that's not what I want to do, if my actual intention is just to wait several hundred milliseconds until this is finished, then it would be nice if I could just write my code, line by line, so we know we can read it from top to bottom and just do things in the order that we see them. So that's what await does. It means that instead of just getting a promise back from Axios.get, our code is going to wait on line 34 until this request actually finishes, and then the actual data will be assigned to response. So you notice just in the variable name, I'm calling this response instead of request promise, because this actually gives us the data immediately. Well, I mean, we still wait just as long, but I don't have to define a callback function. I don't have to, I don't have to like manually manage the promise. So this is what that looks like. We can see we got the same data back. Information on Bulbasaur. But now if we wanted to do a subsequent request, we get this next URL. Okay, so we send the one request, and then the response is assigned to a variable. I'm going to get the URL out of that response by digging in several levels deep to where I know it's at. And then we send another response. We send another request with Axios. So now we're getting that secondary response back. As you can see, this isn't a request for Pokemon. This was a request for types. We requested information about the grass type. And so this is telling me all the grass Pokemon, all the different grass moves. So this works exactly the same way as the code that I wrote before, but with the advantages of I don't have to indent my code so much when I write it like this. I have multiple subsequent requests, multiple consecutive requests, and they're all just one line after another, no indentation. But also, now that I'm using async await, I can use try catch again. So like, again, I'm going to break this URL. I take the H out of there. That's like super broken. We get all these errors. Now I can try. Now I can use a traditional try catch block. And at least one of those errors is now being caught by my try catch code. So I can handle that slightly more gracefully and do something intelligent when it doesn't work out. Kat?
I'm just wondering if you're doing an API call, can you ever separate these out into separate functions, or would you always put them all together like this?
Can you elaborate on that?
Well, like here you're doing the first response and then the next URL, next response, all together and get Pokemon. Would you ever break up multiple API calls on the same page, or would you always put them in one function together?
It depends, I guess, on how you're using them in the other parts of your application. So in this case, I just have one example that just does one query and then another related query. But it could be possible also that maybe there are a lot of reasons why I would look up a Pokemon, maybe not necessarily to get their type, but to get other information about them. So I might just have one function that basically just does this one line of code, a function just to get Pokemon, and then another function that takes a Pokemon and gets information about their type. So just depending on what I need to do, I might break things into functions differently. Just things that are always called together can go in a function together. Things that are sometimes combined with other functionality, you probably want to break those apart into separate functions. Does that make sense?
Yeah, definitely. Thank you.
Cool. Any other questions?
Yeah, I just have a quick one. What is E?
Oh, that's just the error. I could have called this anything. E is conventional if you're lazy. There's 3 hands. Who wants to ask first?
So in this example, if the second URL was the broken one, but the first one worked, would both of them be considered an error, or would we be able to keep the information from the first link? Did that make sense?
So you're saying this URL is fine. So you want to know if it's possible that this request fails, but we still have access to this data?
Yeah, I was just curious if we still had access to that with the way that the code's written right there.
We have to structure it a little bit differently. So I'm going to define the response up here. And we'll assign to it like that. Okay, so the first request should work now. The second request should fail because this is not a valid URL. But before the second request fails, we are assigning this response to this variable, which is defined outside of the try catch. And then again, outside of the try catch, we're going to try to log it. So this should show us that. Yeah, so definitely still telling us that things went wrong, but we do see that response because we were able to store it in a variable before our program crashed, and then we handled it and we're able to continue on afterwards. Sound good?
Yeah, cool. Thank you.
You're welcome. Any other questions? Kat?
Oh, sorry, I just forgot to put the hand down.
No worries.
Are you showing us how to utilize like this information today, or
What do you mean?
like the data that we got from the API, using the DOM to actually print that on our web page?
Oh, sure. I guess that would be interesting. So let's see, if I just want to like put his name on the page, it's going to be data.name. This is probably the most quick and dirty way that I could do this. Yeah. But so, you know, like the other day, Ankur showed you those DOM manipulation methods. You can use JavaScript to just create divs and just set their inner HTML property to whatever. So you could do that kind of here. So this was a pretty simple example. I just appended it to the bottom of the document, but generally speaking, you're going to grab some raw data, you're going to create an HTML element, and you're going to assign the inner text or inner HTML of that element to be what you got back from the API. Although when we get to React, it's going to look a little bit different.
How much time? So with that being said, I guess how much time should we focus on like practicing this if we're going to do it differently with React? I mean, I know that we need to understand it, but.
So the sending the request part and the accessing the data part, that's going to be the same with React or not. How you get that displayed on the screen, that's going to be a little bit different. So I'm not asking you to focus on that part too hard for tonight's exercise. But we're going to definitely cover APIs more, again, when we learn React to see how this specifically integrates into a React application. Because just like you're mentioning, there are a couple additional complexities.
And are we learning how to store the API key next week? If there is a key to the API? Sorry.
Yeah, so I deliberately chose this API because it does not require keys, because I wanted you to just send and receive data before we dealt with all that nitty-gritty stuff. But definitely moving forward, you're going to have to deal with that. So for your personal projects, root projects, you're probably going to use some public API. And most of them will require you to authenticate before they'll just give you data that you request. So you're going to have to read their documentation and figure out how you get a key and how you add the key to your requests so they know who you are. So that's definitely an important topic to understand, and we'll cover that in the future. All right, any other questions?
I've got one, Raphael. Just to make sure I understand how Axios works, like Axios.get, you're always going to put a website in it, right?
It's a URL, yeah.
Yep. So a URL, and from that, it's going to return to us like an object that we can work with.
It returns a promise, which you can either await, returns a promise, which you can await to get the data, or you can call .then off of it to get the data. But yeah, indirectly, it does get you the data from the website.
Okay. So the data on websites, is it always like going to be returned to us in that sort of like almost like JavaScript object format that we have right now?
Most commonly. So like you would have to read the documentation to figure out exactly what it does. So, and they do say it's a modern RESTful API. People usually assume JSON, in that case. I read the actual documentation. So yeah, it does kind of mention throughout that this API returns JSON data. I'm sorry, what was your original question?
No, I just wanted to make sure like I understood what was going on.
Okay.
I got it. That explains it.
Cool. All right, any other questions?
I have more questions, but are you about to release us for lunch? I didn't want to ask them if.
I mean, yeah, as soon as people stop asking questions, I was gonna let you all
Okay.
go. Maybe review one of the exercises for tonight or just introduce it, but yeah, there's no more content.
I was just curious what the difference between super agent and Axios is.
Super agent. I've never seen this before, but it looks like basically the same thing. So Axios is not unique. There are many libraries that do pretty much the same thing that Axios does. I chose it because it's pretty modern. It's the HTTP library that I've used in like my past 3 or 4 jobs, I would say. So it's pretty popular. I thought I could serve you best by showing you the one you're most likely to use in your actual job. But there are certainly other alternatives. This looks like it does basically the same thing as Axios. I'm not sure why you would prefer this over any other HTTP library, but it looks cool. Yeah, it's always good to be aware of the alternatives, just different tools that are available in your ecosystem. I was trying to keep it simple for you all today and just show you one way of doing things. But you might decide at some point that you have very specific needs and that Axios doesn't quite meet them. And maybe there's some other HTTP library that you want to use instead. All right, so let's just take a quick look over at all right. So you got a couple of basic like HTML, CSS sort of exercises, just flexing those skills a little bit more. Here we have one API related exercise. So it's going to be kind of similar to some of the stuff I showed you today. You're going to be using the Pokemon API. But the goal for this exercise is to build a thematically similar team. So we want to pick a set of Pokemon that all share a type. Imagine, I don't know if you play Pokemon, all the gym leaders, all like the bosses of Pokemon, they always have a team that's 6 Pokemon of the same type. They always have that theme going on. So we're going to try to do something similar here. You're going to pick a random Pokemon. So it's just you pick a random ID number, basically. You request them from the API, figure out what type they are, and then you request data for 5 other Pokemon that share a type with it, and then you display their pictures on the screen. So you're going to be using those DOM creation methods to create 6 ING tags, set their SRC property to the images that you find for the Pokemon, and then just put them on the screen. So that's going to be a pretty basic like API-backed application. So just a little context. You shouldn't need to know anything specifically about Pokemon to do this exercise, other than the fact that they all have ID numbers that start at 1. They have 1 or 2 types, like fire, grass, or flying. And then also a bit of terminology. A sprite is a name for a 2D image that's often used in developing games, for example, Pokemon. So you might have noticed in the API response that I was getting, where is it? So in the API response, it has a sprites property here. This is where all the pictures of this Pokemon are at. So it's just a little video game terminology for you if you're not exactly sure what that means. So yeah, that's what we're going to be working on tonight. Any questions about the exercise or about the demo today, or just anything we got going on?
Will we be using more APIs next week?
Yeah, I want to say by the end of next week, we're going to start using APIs again. But it's going to be different though. Here we're using APIs from our front end with JavaScript. So next time we're talking about APIs, we're going to be using APIs from the back end with Django. So some APIs, you just can't use them from the front end. They have extra security and they won't accept requests from a browser, and they need to get it from a server. So we're going to show you a couple of different ways that you can consume data from an API. Andrew?
Oh, I just forgot to put my hand down.
Oh, that's weird. It just showed me your hand, like all of a sudden.
Oh, really?
Yeah,
Oh, must have been some bug.
weird. Okay. Oh, wait, one last thing I want to show you. So if you're looking for some inspiration for your personal projects or group projects, there's this really great GitHub repo, just public API/public APIs, which is a big list of public APIs that you can use. They've got a whole bunch of different categories. Let's look at animals. So here's a whole bunch of different animals, or a whole bunch of different APIs that will give you information related to animals. And there's some information about how to use the API, like if you have to authenticate to it. The ones that don't require authentication are probably going to be easier to use, but the ones with the best data are going to require you to authenticate.
Are you meaning to share your screen right now?
Oh my gosh, yes. I'm so sorry. I turned off the screen share like 2 seconds ago. Jesus. Thought I was done showing you things. Yes, okay. So this is a really handy GitHub repo. This is actually linked to from the curriculum document for today, but it's just a list of public APIs in GitHub organized by different categories. So let's say I like books. Here's a whole bunch of APIs that just give me information about books. Some of them are for querying like specific books, like religious texts. Google Books is more general, should be able to show you like any published book in the Western world, I think. Yeah, so if you're thinking you want to build an app that relates to restaurants or language or finance or something, it might be useful to look through this list and see if there's some external data source that you can pull in to make your app more interesting quickly. Yeah. Okay, so that's actually all I wanted to show you today.
Where can we get that link?
It is linked in the curriculum document. So yeah, so in the APIs section up here, there are many free public APIs. That's just going to take you right there.
Do these free public APIs still require like tokens and different ways of getting information?
Many of them do. So in this table over here, it'll tell you auth is either you can send a request with no authentication, or they require an API key or some other specific form of authentication.
Are some APIs written in like CSV, or are most APIs written in JSON?
For sure, most APIs will give you JSON data. Some APIs, though, will let you choose the format. So there will be like an extra URL parameter you can add for like format equals JSON or format equals XML. Maybe some APIs would give you the data in CSV. I'm not sure if I've heard of that recently. But yeah, it's not uncommon that an API could provide the data in multiple different formats upon request.
And then how to use a JSON in like Python? Since, yeah.
That's a good question. Don't remember offhand, but it's certainly not hard. Okay, so there's a built-in JSON module in Python. And so you can call json.dumps and you pass in basically any data structure that could potentially be converted to JSON. And then it returns a string of JSON. So, it's not exactly the same as the Python because Python and JSON don't have the same data types. So, null or none in Python turns into null in the JSON, but it's as similar as it can be. And also note the quotation marks on the sides here. So this is a string that it gives you. And then similarly, on the other hand, json.loads, you pass it a string of JSON, and it gives you a list or a dictionary. So yeah, Python has this built-in JSON module that you can use for managing JSON data. Although honestly, when we're working with Django, you might not have to be manually like parsing and unparsing your JSON data, but in some cases, Django will do that for you automatically because it knows what you're trying to do. It knows you're receiving JSON data over the web because that's how APIs work. And it knows that you want to get it as a Python list or dictionary because you're building a Django app. So Django is going to try to be smart and do some of these things for you automatically. All right, I know we're going a bit over, but got some good questions here. Do we have any more last minute questions before I release you for lunch? No questions. All right, so sorry for going over a little bit here, but I think that's gonna conclude this morning's lecture. We don't have anything else scheduled for this afternoon. Let's have stand down a little bit early. Let's try stand down at 4:30 this afternoon. Let you all start your weekend a couple minutes early. But other than that, hope you enjoy your lunch. Reach out to me on Slack if you need anything. I'm sorry, Andrew, did you have your hand up?
Yeah, was there a consensus on whether or not we were going to do the optional breakout session?
My understanding is that it is in fact happening.
Yep. Yeah, we'll do that at 1:30, probably just for an hour. Don't make it too long. And you guys got your social activity at 3. So yeah, we'll try to cover whatever we can in 1 hour and go from there.
I have a question, but can everyone like not feel like they have to stay for this? Someone said they're hungry in the chat, so.
Okay, sure. So morning lecture is over. Question lecture is opening now.
So back on the API list that the GitHub page, it says auth, which is like the API key, and then HTTPS, and then cores.
Mm-hmm.
What do those things mean?
So let's see here. So auth, that's whether you can just send a request anonymously or if you need to sign up and be logged in. HTTPS is if they just have a secure HTTPS URL, or if you have to send the request to an insecure HTTP URL. So that has implications about the security of your request if other people can potentially snoop on it. So, if you're transmitting sensitive data to and from the API, you would probably prefer an API that uses HTTPS. And then cores is whether the server for this API allows other origins to use this response. So in effect, what this means is, do you have to consume this API from your server, or can you also do it from the front end? If it says yes for cores, then you can consume this API from your front end in JavaScript from your browser. If it says no for cores, then you need to use a server to send this request, because cores is a restriction that only applies to browsers.
Okay, cool. That's helpful. I want to be able to build some stuff soon, so that's good to know. Thank you.
You're welcome. Any more questions? All right. Thank you all for your questions. They're really great. Just love all the listening and the focus. I just enjoy talking about this stuff. It's fun for me. So hope you all enjoy your lunch. Take care, and I'll see you all at 4:30 tonight.